Here we're going to look at question 4 from section 2 of the ENGAA 2018 paper. In this question, we're told we have two bar magnets set up in the configuration shown in this diagram. We're told that the mass of our bar magnet X is double the mass of our bar magnet Y. We're then told that initially the magnets are held at rest, but then they're let go of, and they speed towards each other, and then the speed of X is going to be v right before the two magnets collide. We're also told that in this collision our two magnets coalesce and stick together. Then the question asks us, what is the velocity of our two magnets right after they've collided? If you would like to have a go answering this question yourself, then please pause the video now, otherwise let's have a go at it. So since this is a collisions question, what topics could we try and use to help us solve it? Well, perhaps the most useful one to use with collisions is always conservation of momentum. Now we could try and use conservation of energy, but while energy is always conserved, it can often be radiated off in forms of like heat and sound, and where this energy is radiated off isn't always clear in our equations. So sometimes we account for energies which we don't have, and we can end up with the wrong answer. But conservation of momentum is always going to hold, so we should probably start by using that. So bearing that in mind, let's consider the momentum of our two magnets when they're held at rest initially. So since the two magnets are just at rest, there's going to be nothing moving at all, the total momentum of our system is just 0. Now next we could go ahead and think about our magnets just before the collision, but how about we just go to the very end and look at our answer? Then if we need to, we can come back and look at the magnets just before colliding. Now, since momentum is conserved, after the collision, the total momentum of the system has to be 0 as well. But we know that after the collision, our two magnets have coalesced, so there's just one single magnet and one single mass. So the momentum of this one mass is going to just be its mass multiplied by its velocity, which I've just called u here. Now, obviously, the final object isn't going to have a mass of 0. So, therefore, it must have a velocity of 0. So, after the collision, we know that the magnets are going to be stationary together. So this is quite nice and easy. We didn't have to consider the collision we didn't have to consider the magnets just before colliding. And therefore, our answer is just going to be A, that the magnets are both stationary.